Good afternoon, everyone. My name is Supraja, working as Assistant Professor in the Department of Civil Engineering at B.V. Raju Institute of Technology, Narsapur, Medak. In last class, we have seen about the friction concept and its applications in real time. In today's lecture, we'll see about the ladder friction. How the friction we can apply to the ladder, that is a real-time example. That is, the problem is a ladder of weight 1000 newtons and length 4 meters rest as shown in figure. If a 750 Newton weight is acting at a distance of 3 meters from the bottom of the ladder, it is at the point of sliding. Determine the coefficient of friction between the ladder and the floor. So, there is a ladder of weight 1000 newtons. Ladder weight is 1000 newtons and the length of the ladder is 4 meters. And an additional weight 750 newtons is acting at a distance of 3 meters from the bottom of the ladder. At this location, what happens? There will be a sliding action of the ladder. So, that is mentioned in the question. Now they are asking us to determine the coefficient of friction between the ladder and the floor at this point A. Now, there will be a procedure for the friction concept to analyze the problems. That is, the first one is drawing of a free body diagram and then application of equilibrium equations to solve the numerical problem. So, first we'll go to the free body diagram. So, free body diagram, that is FBD. FBD is nothing but removing of all contact surfaces. Free body diagram is nothing but removal of all the external forces acting on a body and keeping reactions in the place of contact areas. Now, first we'll draw the free body diagram of the ladder. So, this is the ladder. This is a point A and this is point B. The length of the ladder is 4 meters, which is given in question. This is the 4 meters length of the ladder. So, we are removing the contact surfaces from the ladder. That is, one is a floor is contacting at point A and wall is contacting at point B. So, we are removing the floor and the wall from the ladder. Now, we have to keep the reactions. One is a normal reaction at A and normal reaction at B. So, normal reaction at A will be in upward direction, that is NA, and at B towards right. This is the normal reaction from the floor. It is the normal, NB is the normal reaction from the wall. Now, there will be a friction. So, at the sliding, the ladder will slide. So, at point A, it will slide like this towards right, and at top, that is at the wall, this will slide towards down. So, now frictional force will be opposite to the sliding action of the ladder. So, and in case of point A, ladder will slide towards right. So, frictional force will be opposite to the movement of the ladder, that is, frictional force will be towards left. This is at point A. Now, coming to the point B, here there is no case of friction between the wall and the floor. So, in question, they are not mentioning about the frictional force or coefficient of friction between the wall and the ladder. But at point A, they are asking us to find the coefficient of friction between the ladder and the floor. Now, there is no case of frictional force at point B. So, that is actually it will act towards up, but at point B, there is no case of friction. So, FB will be 0 in this case. Now, there is a self weight of the ladder that will act exactly at the center of the ladder. So, this is 1000 newtons, and there is an additional weight 750 newtons is acting at 3 meters from the bottom of the ladder. That is, this one is 3 meters, and self weight is acting at a distance of 2 meters, that is exactly at the CG of the ladder. So, this is the free body diagram. Now, we need to find out the coefficient of friction between the ladder and the floor. Now, we have to apply the equilibrium conditions, that is sigma h equal to 0, sum of all horizontal forces equal to 0, sigma v equal to 0, that is sum of all the vertical forces acting on the ladder will be equal to 0, and sigma m is equal to 0. It is nothing but summation of all the moments produced by the forces either at point A or at point B. So, now we will apply one by one. So, first we will take sigma h equal to 0. Horizontal forces. What are the horizontal forces applying on the ladder? So, at point A we have FA, and at point B we have NB, and vertical forces are 1000 newtons, that is self weight of the ladder, and normal reaction at A, and there is a additional weight 750 newtons is acting at 3 meters from the bottom of the ladder. Now, coming to the horizontal forces, now we are applying equilibrium condition, that is sum of all the horizontal forces equal to 0. Now, there are some assumptions for considering the sign conventions. So, the force which is acting, sign conventions are the force which is acting towards right, we are taking as positive, and the force which is acting towards left as negative, and the force which is acting upward direction is positive, and the force which is acting downward direction we are considering it as negative. So, now at point A we have FA, it is acting towards left, that is minus FA. So, the force which is acting left we are considering as negative, and another force we have at B, that is NB. NB is acting towards right. So, right side force we are considering as positive. So, FA minus FA plus NB is equal to 0. So, from this we can write FA is equal to NB. So, let us assume this is equation number 1, and next let us consider sigma V equal to 0. So, we are applying equilibrium equations one by one to simplify the numerical equations. Now, let us consider sum of all the vertical forces equal to 0. So, what are the vertical forces here? We have one is NA at A, and there will be a 1000 Newton force at midpoint of the ladder, and there will be a additional weight 750 newtons at 3 meters from the ladder, and FB will be 0 in this case. Now, NA is acting towards upward direction. So, upward force we are considering as positive, that is NA is positive, and next we have 1000 Newton force, it is acting towards down. So, downward force we are considering as a negative, that is minus 1000, and there will be an additional weight 750 newtons it is also acting towards down. So downward force we are considering as minus. So minus 750. So is equal to 0. From this we can write Na as 1750 newtons. So let us consider this as equation number 2. Next, let us consider moments about either A or B equal to 0. Now, here I am considering moments about A is equal to 0. So, what are the forces producing moments about point A? So, here FB frictional force at B will be 0 and there is a NB, so which will produce the moment about A. So, this NB will be in clockwise direction. So, NB will produce the clockwise moment. So, clockwise moment we are considering as positive and anti-clockwise moment we are considering as negative here. So, NB into perpendicular distance will give the moment due to normal reaction at B at point A. So, this will be this. This is the perpendicular distance between force NB and the point A. So, it will produce NB into perpendicular distance is, here the angle is 60 degrees. So, the NB is acting here. So, the perpendicular distance is this one. So, how will get this NB into perpendicular distance here? NB into this is like a right angle triangle. So, in this case, so this, for example, let us assume this is point C. So, BC will give the perpendicular distance between NB and point A. So, this is by considering sine 60 degrees. So, sine 60 is from the triangle ABC, sine 60 will be BC by, that is opposite side by hypotenuse, that is AB. So, from this we can write BC is equal to AB into sine 60. We know that AB will be the length of the ladder, that is 4 meters. So, BC we can write 4 into sine 60 degrees. So, now we got the perpendicular distance between NB and point A. So, we can write NB into 4 sine 60 degrees, that is, this is the ladder, here NB is acting, this is point B, this is point A. Now, this is the self weight of the ladder 1000 newtons and this is the 750 newtons additional weight. And the angle between the ladder and the floor as 60 degrees. Now, this is point C. Now, we want NB into perpendicular distance, that is BC, we got 4 into sine 60 degrees. Now, there will be another force, that is 750 newtons acting on the ladder. This will also produce moment at point A. So, the perpendicular distance between the 750 newtons and the point A is this one. So, we know this position of the 750 newtons, that is 3 meters from the bottom of the ladder. Now, 750 newtons is producing an anti-clockwise direction, that is this 750 newtons will produce moment like this in anti-clockwise direction. So, that is minus 750 into perpendicular distances from here to here. This is the perpendicular distance. So, by taking the opposite side in a triangle, we will get this perpendicular distance, that is, this is opposite, that is sine and this is cos. Now, we want adjacent side of the triangle to get the perpendicular distance between 750 newtons and point A. So, that will give, and the distance is 3 meters. So, we will get 3 into cos 60 degrees. Now, another force is acting, that is self weight of the ladder 1000 newtons. So, minus So this will also produce an anti-clockwise like this. That's why we have to consider it as minus anti-clockwise, minus 1000 into perpendicular distance between the 1000 Newton force and the point A. So that we want this small. So we know the distance between 1000 Newtons and the point A, that is 2 meters. So by taking the adjacent side of the triangle, we'll get the perpendicular distance, that is this one. So in this small triangle, if we take this as a small triangle, so this is 60 degrees, we require this. So this is opposite, this is adjacent. By taking the adjacent side, we'll get the perpendicular distance here. This is the 2 meters distance. By taking adjacent side, that is cos 60 degrees is equal to, say for example, this is A and this is point E and this is point F. So AF by AE, that is we want AF is equal to AE into cos 60 degrees. So AF is equal to, AE is nothing but 2 meters into cos 60 will give the perpendicular distance between 1000 Newton force and the point A. Now 1000 into perpendicular distance is 2 into cos 60 degrees. So there are no other forces acting here. So equal to 0. So here FA will be acting towards left and there will be a normal reaction acting towards up at point A. But these two forces are acting exactly at the point A. There is no perpendicular distance between the forces and point A. So because of this reason, FA and NA will produce the zero moment at point A. Now by calculating or by simplifying this equation, we will get NB as 613.45 newtons. This is the normal reaction at B. Now from equation 1, we can write FA is equal to NB. That is FA is also 613.45 newtons. Now we know the coefficient of friction definition. Coefficient of friction is nu is equal to frictional force by normal reaction. Now we are finding the coefficient of friction between the floor and the ladder, that is at point A. So let us consider it as mu A is equal to FA by NA. Now we got the value of FA. Now we require NA value. From equation 2, we know the value of NA, that is 1750 newtons. Now by substituting FA and NA in coefficient of friction definition, we will get mu A is equal to, that is 613.45 by 1750. We will get the coefficient of friction between the ladder and the floor, that is 0.35. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.